So I've taken apart my mouse here, and it's got some nice advantages compared with other mice that have broken on me in the past. The housing is nice and rigid at least. You can see what's happened here. Here's the mouse wheel. Right in here there's a little piece of plastic that goes on the end here, which happens to be sitting right there. And that little piece of plastic is actually hexagonal, and it fits into this hexagonal hole over here. Initially I was planning on just gluing it back on, but it didn't exactly break in a perfectly planar way. Having lost this tiny part numerous times, it's very difficult to pick up, and like sanding that part down would be probably next to impossible without building something like custom to hold it. So it would have to be glued on there in exactly the right orientation, and I still think that I might try that first. But I have come up with an alternate plan. I found the smallest dowel I have, which is a toothpick, and this drill bit is 5/64ths, which is the smallest drill bit I have, I believe. And I tried it out, and that actually fits pretty good. Yet the toothpick itself is too big. And this is one of the miracles of this design that makes it maybe good, as bad as it is to rely on that tiny piece of plastic never melting on you. This mouse wheel has been on its last legs for years. I've been babying it. I'm pretty sure it was partially broken for years. But it must have been pointed just the right way, and I pushed down just a little bit too hard, and it snapped off this morning. I actually tried all my Allen keys. I have some small Allen keys. I have two that are small enough to fit through here, yet both of them are too small. But also, and you won't be able to see this really, while this is hexagonal, it also has a bit of curvature, and that allows the mouse wheel, when it's in the housing, this bar presses the click, and this end is where it's supposed to drives the sprocket over there. So this spins nicely in here, and I have to maintain that. And this shaft is actually a little bit smaller than there. But back to the miracle of the design, they actually left a hole over here, which is perfect to guide my drill bit, so I can drill a straight hole. Unfortunately, my drill bit doesn't fit. So what I would do is go backwards for a while to try to get it going in the right direction. And then I consider drilling forwards, but the drill bit's actually smaller than the shaft on this end. You can see there. So because the drill bit is smaller, if I am even a little bit off center, it's gonna basically make this part completely useless. And then it would be resting on the wood there, which is fine. This is actually, gravity goes this way, so it's not that. If I had a little play there, it would probably be okay. I could wrap this in tape or something to make up for the difference if I do end up breaking this nub off here when I drill it, which is very likely, because the chance of drilling through perfectly and then maintaining a hollowed out tube on this end is very low. But the plan ultimately would be to drive this all the way through, so it would become much more rigid, and then to whittle a little bit away to create a hexagonal end on this toothpick, which I've already broken off here. And the way that the original design was hexagonal and rounded. I get the feeling that this is going to wear out too, but at least it'll have a little bit more rigidity. It should transform the torsional force adequately. I've been debating it. Did I just break this when I took it apart? I don't think so. But that is really the only thing holding up the other side of the wheel. I tried turning the screen thing, and I could see that by rotating this, it scrolls on the screen. So I know that this is working, and I know all the other buttons are working. So it is really just the wheel motion itself for scrolling up and down that's broken. So yeah, which method should I use to fix this? The glue method is definitely probably something that could work if you use super glue and get it aligned just right. Then I would try to put some super glue on the paper, take this thing, figure out the alignment. I need to clamp this better. Touch it into the super glue, and then just set it on there somehow, and then try to let go and hope it stays where it's supposed to be. I can't really clamp it while the glue is setting, and it's going to be rather brittle. So I was going to clean it up first with some rubbing alcohol to try to get the glue to bond better, and possibly try to rough up the surface to get the glue to bond better. None of which is very ideal, and I really kind of don't want to have to do this again in the future, so I think we're just going to go ahead and drill it. I have another mouse plugged in already, so I do want to ultimately fix it. But if I mess up this part, it's definitely going to make things more difficult down the road. But on the fortunate side, like this tube is there, and it's going to make this a lot easier. You notice I'm running this in reverse, and that's because I want to get it aligned right. The hole is just a little bit too small. And you'll see we've gone in about 1 millimeter so far. Now, I don't want to hurt myself, so I'm just going to be really careful and go slow. So you see it's a little off kilter already, and I don't really like that. We try to hold it a little bit better, but the whole drill is off kilter. So I've gone in about 2 millimeters now, maybe. And so far so good, I think. About as good as I can expect. We don't want this to heat up an extraordinary amount. And there's an argument that maybe I should try to clamp this down and try to work like this, but it's actually, I don't have a level in the back of my drill. So it's really hard to keep the drill going in the direction. I don't even know if this surface is level. So I think I'm probably just going to keep going like this for the time being, to try to get, and I really don't want to I don't want to see any drill bit anywhere over there. It has to go all the way through the very end. And that's probably not going to happen, but we'll see. So this is definitely a pretty finicky repair. That sounds. So I think I've gotten just about to the bottom of that existing hole. So hopefully that will serve to guide me the rest of the way through. Do have the bright light here. Yeah, I don't see it continuing. There might still be a hole there, and it's just plugged up with shavings right now. So we'll try to go forwards a little bit with the forwards motion of the drill. First I'll go backwards and get fully seated again. Then we try to go forwards just a little bit, and it is going forwards a lot, really fast. You can feel it. So it is just shavings in there. And we'll try to hold the drill steady now and pull the shavings out. I'm not going forward at all now. Run it forward and pull it out. So we're just trying to get some shavings out of there. You can see a couple shavings on there. And this is pretty much solid plastic on here. So got some shavings out. Going low speed, I think it's still centered pretty good. One way to check center is try to put your shaft in there and spin it to see if it's wobbling. And this actually looks pretty good to me. So I think we're still headed in the right direction with the drill bit here. You don't want to rush it. Alright, I'm going in reverse again because that's the safest way. When the bit is traveling forward, if I had it off at all, the bit can dig in. So we're going in reverse. We're going to get the bit seated wherever we're drilling, and we can run it, and we can see Yeah, I mean, there's something a little off there. And what is it that's off? I think, I mean, it's really tough to say between the chuck, the looseness in the bit here, and so, I mean, I could see it right there, is that this bit is going too far towards this point, so it's going to come out right there. So I'm going to hold it right here. I'm going to go backwards a little bit more. Now, changing a hole once it started is impossible. So, you know, we're just trying to wear away a little bit. And then ultimately we're going to go forward with the drill, and then without moving the bit further in, we're just going to try to wear away a little bit. Okay, so I don't know if that did anything, but you know, we tried at least. So at some point we're just going to have to drill and see what happens. You know, always being careful, you're not going to drill into your finger. You got to be careful. There should be just plastic all the way through. So we're going to apply a little bit more pressure, and we're going to drill forwards. It's the only way forwards at this point. And I can see that I've made a couple millimeters progress forward. I'm going to mark the drill bit right here, about 1 full rotation. And then we're going to keep it going forward but pull the bit out. And that's just excavating all the chips. And the color's changed. That almost indicates that I've gone through and hit the wood to me, but no. It's just more plastic chips. Maybe there's some glue in there that I hit, and that's why the color changed. So yeah, if you can see in there, it's going to be a miracle. This is a bit bright for me. You almost need to wear eye protection with these LED flashlights. There, it can be a bit too bright, a bit over bright. You want to wear like UV protection, even if it's clear lens glasses, just to protect yourself. I often wear sunglasses when I'm working on things, but that's also dangerous because, yeah, you can't see. So ultimately, we're, like I was saying before, we got about 1 full rotation. I mean, a little bit over a full rotation. So that puts us about there. So we've actually started to just barely drill into the little bit that we don't want to destroy. So I don't see anything coming through yet. If I could just buy this part, that would solve this whole problem. You know, if I find a way to buy this part, I'll definitely add a link in the description. I'm not a pro gamer, so I don't, you know, while I do play video games, I don't have the money to spend on another mouse right now. Let's take a look and see if we can get through the rest of the way here. Now if I see it come out where I don't want it to, I don't know what I'll do. Will I just keep going? So I can already see it's coming through right here. So see how it's going off the center? The plastic is being deformed here, and the pressure, me pushing on it, was enough to push it off center. So at this point, maybe we consider just cutting that nub off of there, and we will instead work our own solution. So the problem here that I encountered is I was actually going the right way, but because it was a little off center, I was going a little bit too fast. It got a little melty. And once the plastic starts to melt, you're kind of SOL. So, you know, I kind of thought I'd have to do this anyway, so we're just going to cut the nub off and then cut it off right here with the X-Acto knife. Another tool that I should have readily available here. So you can use a little X-Acto like this, and they're really handy to have a little X-Acto, but sometimes you want to have a stronger blade, be able to get a little bit more leverage, get your hand around it. So here's my my X-Acto. This definitely could use a blade change, but I think it'll do the job here. So I'm going to use the end of my horse, and you know, you can see how this blade can go beyond the end, right? So it could come down and get my fingers. So I'm being careful with my fingers, and you know, it's all just going to go free once this cuts. There we go. So we've cut through, and now we can try to recenter that hole. And this is why this is a nightmare without a drill press or proper drilling apparatus. It looks pretty good now, but you know, we haven't done anything yet. So what we have to do is see which way it needs to go, which is it needs to go up this way. We're applying a tiny bit of pressure while it's running to try to move the hole, and this is really not going to fix anything. I tend to think that'll do. I don't want to overdo it, because if we end up with an oblong hole, it's not going to run right anyway. So it's going to run a little bit off no matter what we do. And there's no sense trying to break a drill bit, trying to move a hole that's already drilled. Alright, so this dowel, aka toothpick, should now fit. And you'll see it does fit. It's a little tight, and we want to see how off square it is, things like that. We need to get our final measurement, which is going to be this plus our additional fiddly little bit here. So adding those together, that's how much we need to protrude. And then before we really drive this through, we're going to try to put our hexagon on it. It doesn't need to be perfect. So the way this hexagon is, there's a flat edge and a directly opposite flat edge. If you got two flat edges on the thing that were opposite one another, and then shaved the other side down, as long as it was tight enough, it would work just fine. We'll try to get all of them, but we have 3 opposing edges. So what I'm going to try to do here is mark the points. So all the points will be opposite one another. So first we'll get 1 point here. And you know, I'm on graph paper, maybe we can use that actually. So if we get it lined up just right here, we'll roll it carefully and we see we get 1 unit. I didn't plan this out, folks. It just works out that way. So that means that if we want to get exactly 1/2, we're going to want to center it in between 2 units. I just got the paper so we wouldn't lose little bits between the horses here. So there we got another mark. Exactly opposite that. Next we're going to need to mark, we don't want quarters because that would be the 2 other marks. And you know, you can actually subdivide your graph paper. No, those are quarters, right? So thirds would be where you got 2 marks. Then that's subdivided. So that's what we want to use, are those third marks. So we'll line it up again, or try to. Line this up here. So we're going to carefully roll up to our mark. Making a mark there. And we'll keep going here. We'll make another mark there. So we need to do the same thing for the opposite side, so we can reset our position on our first mark. And move to here. Make another mark. Move to the other 2/3 position and make another mark. it seems that you can utilize the GoPro while it charges. So we've marked out our hexagonal pin over here. We have 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. 1, 2, 3, 4, 5, 6 to my start mark. And you can see here, all I'm going to do is very carefully try to whittle away in between each mark. I highly recommend this type of X-Acto knife for that sort of work. I had the same blade on here for, oh, wow, hey Tara. Had the same blade on here for ages. And, you know, you buy a pack of blades, it goes a long way. Visit your local craft store. You'll see this is horrendous, but, you know, we've got some flat edges on there. And now it fits in here. And it's enough to turn it. But that seems like it'll do the trick. So the next thing we got to do is drive it all the way through here, and we got to stop at the right point. And that's going to measure out to be I can already see we're going to have problems with this being overly long, so we want to trim down our hexagon. So that turns it, but I actually need this to be through a little further. The tolerances here are rather small, and you may have to fiddle with it a bit until you get one that works, but it seems that it will be necessary to trim it down further. And I need to push it through just a tiny bit more. So now I can trim off the other end. So same as before, I'm going to try to trim it flush. Maybe we'll work over the surface this time so it's a little safer. If you use fresh blades, you will get a better cut. Well, all this charging is making me nervous, but let's see. So, it does fit in here, and you'll see we get a little bit of wobble. I believe I will want to wrap a little bit of tape around here to bring the diameter of that shaft up to match what it was previously. But let's try to put this together and see if it does basically what it's supposed to do. Oh, I neglected a very important part. I'm just trying to cram this thing in there, when in reality you have to put the wheel on first. So our wheel's on, our wheel's where it's supposed to be now. Now we can install it. Feel that it was turning it, but now it no longer feels right. So I don't think that wooden pin is spinning green plastic thing anymore. It just doesn't feel like it is. So we gotta pop it back out and see what happened. And I've always been a little shaky working on the little bits. One idea is just to push the shaft through a little further. Maybe that'll snug it up. That might give us problems getting this reinstalled too. If we're going to trust this hole in the board, you can see that our wheel is too far that way. So what we need to do is move our pin out even further. And you'll see there's so little tolerance here. Push this pin through a little farther. Fix our hexagonal edge. So the real challenge with this is getting this to be reasonably hexagonal so that it will bind reasonably well, but also has to be insanely short. Not sure I'd recommend this repair method. Now if we could bend this thing, if this had any play in it, it would make assembling this a lot easier. But otherwise it seems like you almost have to assemble it in place. Because what I keep doing now is I keep shortening the shaft, and then I need to lengthen it somehow to make it bite again. And then to get it to go through with the wheel fully on there, well, that's a whole other challenge in and of itself. So let's see if we can just keep whittling away at this, and hopefully we'll get something that works here. Now I'll probably cut all this out, right? You know, we'll just see it all go together perfectly. But you know, there was a lot of adjustment to try to get this to sit where it needs to. Now we're trying the blind assembly method. I can't see the board or the tabs or where it needs to go. We're just eyeballing it up from the top. Now in this case, it's that dead side of the shaft that's giving me trouble, and you can't see it, and I can't see it. But I know it's down in that end of it. I'm trying to get that to seat where it's supposed to. So we got that bit, we got that working. I'm tempted to trim the other end of this shaft so that it'll go and properly seat down here. Haha! So, brute force was the solution all along. It maintained the proper alignment. I feel the clicking motion, so I know it's connected to the sprocket properly. So let's try to get this all back together before it falls apart again. So in real life, you probably don't want to use the brute force method. You probably just want to get the pin seated better into the sprocket rather than trying to just force the housing together and hoping everything pops into place. It happened to work in this circumstance, but when it doesn't want to go, the best thing you can do is get out of there and go back to the drawing board, figure out a better solution. So let's see where we're at. So that's still clicking very nicely, and it still clicks too. I mean, clicking like the wheel clicking. So that's working well, as far as I can tell. And we won't know for sure until we plug it in the computer, but so far so good. And this cable got all out of place. So the next thing we gotta do is figure out where that cable's gonna run. It looks like it races right up the side there. And then this fits in this housing up here. Careful, we're not gonna pinch our cable, and it looks like it's gonna miss on that side there, that screw hole, so let's see. Alright, yeah, that snapped together pretty good. Let me just put the last few screws in here. So, you know, where we pulled the feet off up there, we had to cut a little hole down here for the third screw. And there's another little spot up here, you can feel the hole under there, but I didn't cut it. I'm glad I didn't, because there's no screw over there. Well, then we keep going backwards until I feel like it's biting the right way. These are in there real tight. A lot tighter than they need to be, possibly. So I'm not going to over tighten it. I'll be able to remove these again later if I need to. But hopefully this mouse I never open up again. Ultimately I end up opening up almost every mouse I buy, but at least if I do open it up I know what to do next time. I need to replace my toothpick in there, or just push it through a little further and trim it up. And then it should be good to go for another, 100,000 scroll clicks. So alright, that's it. That's, fixed the mouse wheel on this mouse. Of course, I'm going to go test it out and make sure. But one thing that's really nice about this mouse has the braided cable. So when you're going fishing under your desk to unplug it, you know which one it is. So you can just feel like, oh, that's the braided one. So, that's definitely one of the nicer things about this mouse. This is almost exactly the same feel to those Microsoft mice that I used to buy for 60 bucks. It does all those same things, and I think I like it more. It did last longer, but yeah, as we can see, it did break. There's no lights on this mouse, which is really nice. So it doesn't make your whole room glow when you're using it. My mouse plugged back in. I'm testing it out now, and I can scroll up and down, no problems.